Parent function for cubic is y equals x cubed. Yeah, that's garbage. I do like that color though. So if you look, the graph is already there for you. That's the parent function that's already there. Yes. So what is the domain here? Negative infinity to positive infinity. How about the range? There you go. How about x-intercept? 0. So the x-intercept is 0, and the y-intercept is also 0. Oh, yep. What is wrong with me? I'm trying to jump on ahead. How about extrema? Does it have any maxes or mins? Not for the parent. Now, as I start stretching and shrinking and moving and doing all that good stuff, one might occur because I might end up with something that looks like this and I might end up with one. But for the parent function, I don't have any, right? It's always increasing as you go. Y'all okay there? Which brings us to the next question. I didn't see that. Increasing intervals. For what? Yes, yes. Increasing would be negative infinity to infinity. Extrema, none. None. Increasing, we did say, was negative infinity to infinity. Because as you move left to right, that graph is always going up. It never stops going up. It slows down as it goes up, but it never stops going up. And decreasing intervals would be none. See, y'all done this. Y'all know how to do this. In behavior, that's right. And that's right. As I go to negative infinity, f of x also goes negative infinity. The right side goes up, the left side goes down. Does it have any discontinuities? None. It is a continuous function. Yep, a break, a jump, a hole, anything like that. Can you draw it without lifting your pencil? Yes. So no discontinuities. Is it even or odd? It's an odd function. It is odd. 180-degree rotation would map it back onto itself. Huh? Yeah, this is all we're doing. It is. There's just a couple of neat things that I want to talk to you about. All right, flip it over. These are what we call must-know functions. There's 12 of them that you need to know up, down, left, right, sideways, everything, can grasp them, right? And most of them we've done. Square root and cube root should be okay, but when you get to reciprocal, you may not have seen that before, or you don't realize you've seen it. So I do want to run through reciprocal with you real quick. I think you're good on exponential. But definitely sine and cosine. I didn't put tangent in here, but let's do reciprocal together. So reciprocal has two asymptotes like this. It's actually a rational function. Remember we talked about rational expressions and we added, subtracted, multiplied, and solved. It's the graph of a rational, and the parent graph is just 1 over x. These you should know. You're just analyzing from here. If you have any trouble, I'll be happy to help you. We're just kind of skipping around the ones you might not know. The graph's on there. You're just doing the analysis for it. Yeah. All right. So what is the domain? That's right. How about range? Same thing. Same. We'll work on playing around with transforming them tomorrow. Today we'll just focus on what the parents look like. X-intercepts. None. Y-intercepts. None. There are asymptotes on both axes, so you can't have intercepts if there's asymptotes there. In this form, this type of rational function, you'll have the two asymptotes like that, but not every time. We're going to do a whole graphing unit on rationals because it shifted. So if I shifted it, like if I had x plus 2 and then plus 3, so left 2 and up 3, it would. Okay. Thank you. How about extrema? None. Increasing intervals. So as you move left to right, it goes up. None. Does everybody see that? How about decreasing intervals? Negative infinity. That's right. You got to do the u because there is no graph at 0, right? I can't say that I'm increasing at 0 if there's no graph at 0. But I am always decreasing where there is graph here. How about end behavior? That's right. There you go. See, this isn't hard, right? I mean, you can look at the graph and figure out most of these. Yeah, this is it. Just because I really want you familiar with the parent function. Discontinuities. What kind? Infinite discontinuity at x equals 0, because there's an asymptote. Yeah. So discontinuity, infinite, removable, or a whole.
Is this even or odd?
Odd. It is odd.
Wait, how?
If you twisted it 180 degrees, it would look exactly the same. So if you could like put a pin in the origin and twist it completely upside down, would it look the same? Or if you take your picture, right now it's in the top right and the bottom left. If I hold it upside down, it's still top right, bottom left. Even as if the y-axis is a axis of symmetry. As far as what? Neither. All right.
Wait. Why would it be even? How do you know
What? Square root? Because it's not, the left side's not reflected. Like there's only graph on the right side of the axis. Jump down to sine. I'm sorry. All right. Shot for right now. Well, we're fixing to really get deep into sine and cosine and tangent. For right now, let's look at the graph that we have and let's talk about some things that happen here. Let's do an analysis just on the graph and what it looks like. Now, first of all, notice everything that's marked, the units, they're pi's on the x-axis. So in between, it's not marked. So it's a half of a pi, okay? And this is how we're gonna derive the unit circle, so I need you to understand. So every one of these, I start at 0, 0. This is a half of a pi, but we say it's pi over 2. Which means this is 3 pi over 2, which means this is 2 pi, okay? So those are the units that we'll be using. If I went one more, 5 pi over 2, right? What would the next one be? 7 pi over 2, right? Yeah. All right. Are y'all confused about the half pies? Okay. Okay. All right. And I go up to 1 and down to -1. And I never go above or below those values. What? What? The pi? What? So, okay. These, by the way, are in what we call radians, not degrees. We'll get to all that. We'll get to all that. We'll get to all that. That's okay. Let's just look. All right. Pi over 2, 1, pi 0, 3 pi over 2, -1, up, down. And so we end up with this beautiful little curve.
What?
All right, so here's my graph, just so you know what it is you're looking at. What's the domain here? It is. What's the range? Look at y'all with brackets. All right, here's where it starts getting, well, yep, here's where it starts getting a little bit harder. X-intercept. It's every, what? Every full pi. So watch how I'm going to do this. I'm going to write it as a sequence of numbers. Okay? We can do this one of 2 ways. I'll show you both ways to do it. This is the way that students always seem to like the most. -pi, 0, pi, 2 pi, ... Meaning keep on that pattern. You can write it that way, or you could write x equals k times pi, where k is an integer.
What?
You're wrong.
I look at my phone. I look at you got case.
This means is a member of, and this is a symbol we use for integers. Either one of those is acceptable. Either one of those is okay.
So you want to use either K pi or K.
No, like use either this one or this one. It's like a stretched C just a little bit with a line in the middle of it. Okay, just do the dots. That's fine. Dots are fine. All right, those are my x-intercepts. What? The x-intercepts. Because it keeps repeating. It's cycling through, right? Yes. Y-intercept is just 0.
Don't even be like, what is the increase?
All right, extrema. I have a lot of extrema, right? All right, so I have maximums occurring at x equals. Look what's happening. Pi over 2, 5 pi over 2. What would the next maximum happen? All right, pi over 2. So 1 pi over 2, and then I jump to 5 pi over 2. Maximums. Give me one more so I can pick the pattern. Why is it 9 pi over 2? It's every other odd, right? So 1 and then not 3 but 5, not 7 but 9. The next would be not 11 but 13. right? Look at what's happening here. Here, oh, 0. Those are the maximums. This is the first bit of brand new stuff y'all have had, and y'all are like, all right. These, okay, so I'm just telling where they occur right now. If I wanted the maximum points themselves, you're absolutely right. I would have to say there's a maximum at pi over 2, 1. And at 5 pi over 2, 1. These are where the maximums occur. For right now, you can just leave telling me where the x's are here. That's okay. The maximum value that it ever attains is what? 1. Okay, so the max value is 1. Where does it happen? It happens at all of these points. Yes, so you'll want to say a maximum of 1 at x equals da 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 da. Okay? Well, cosine's the same way. The only difference is if you look, it's just shifted over a half a pi. So you're just going to have to make some adjustments. Your maxes become your mins become your maxes, and vice versa and everything. Well, actually, not quite, because it's shifted a half. You'll see. All right, how about the mins? So let me, okay, so minimum of, this time, what's the minimum value? A minimum of -1 at where, what's the, that's the, right. Value is the y, so what's the y value of the minimum? What's the lowest the graph ever goes? Right, right. Not the same thing. The same way, yes, the same concept. So here, instead of pi over 2, 5 pi over 9, it's going to be 3 pi over 2. Where's the next one? 7 pi over 2. 11. I could have done the negative, you're right.
Wait, and why is it
Pi over 2 is a maximum.
every other odd? Is that, so like every odd number? Not that one. Yeah, so every other.
If that's the way you understand it, yes.
Because if you other odd,
Yeah.
every odd would be 35, not every other. Where was that in the graph?
Okay, so each tick mark on yours is pi over, is a half a pi. So this one's not written on yours. This one's not written on. You have a tick mark there, but they didn't indicate what it was. They're half pi. I didn't. You don't have to, as long as you have enough to pick up the pattern. Yeah. Oh, how about in behavior? Oh, did I skip that? Oh, sorry. Okay, increasing. Give me one increasing interval on here, just one. Remember, you're talking in terms of x. Yes, Brian. Right? Look, from here to here is increasing. But that's not the only place it's increasing. Give me the next increasing. 3 pi, that's right. So where do you think the next interval? 2 is probably good on this. If you want to do u dot dot dot, U dot 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 this way to indicate that it's forever, yeah. Parentheses good. Parentheses. How about decreasing? So that's the other number, that's right. Now this time I'm going from pi over 2 to 3 pi over 2. So I'm taking the middles of these, right? Pi over 2 to 3 pi over 2. Five pi over 2. 7 pi over 2. They're happening at half pies. Cosine's a little easier because most of your stuff's going to happen at whole number pies instead of half the pies. So we're doing the hard one together, and then let you do the easy one. All right, almost done with the hard stuff. What does the end behavior look like? Okay. Oh, whoa, 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 whoa. All right, as x approaches infinity, f of x,
1.
always?
I don't know.
This is something new.
Like 1 to negative. Oscillate.
What does oscillate mean? Think about that fan that you got that your grandma probably had that stood in front.
I have one.
Do you have one? My grandma always had one. I don't know why it made me think of my grandma. Oscillates between, what does it oscillate between?
1 and negative 1.
1 and negative 1. Yep. Same thing as I go to negative infinity. It's oscillating between negative 1 and 1. Are you okay? No.
Real. Out of all the stuff they like to do, I'm writing that.
I'm so sorry, Madison. I do that, so I don't write it in a second. You've never seen that, and it means repeat what's right above it? Yeah. No, because it really doesn't approach negative 1 and 1. It like just this one's a little different. I'm sorry. Y'all get so mad with me whenever I show you something and I tell you if it has to be a certain way. Y'all like ah. I promise I didn't make it up. What? Yes.
Yeah,
Even or odd? Even or odd?
It's all. I think it's none.
I think y'all are just throwing stuff out, man.
Why?
It's actually the multiplication.
Okay, if you fold the paper in half on the y-axis, does it mirror? It's not the same, so it's definitely not even. If you hold it upside down, is it exactly the same? Yes, so it is odd. Yes.
Oh, I thought you meant if you folded it.
No, like if you take your paper and you hold it upside down. So for this one, it goes through 0, 0. It goes over 1, up 1. So if you turn it upside down, does it go through 0, 0 and go over 1, up 1? What are you looking at?
Oh, I was looking at cosine.
Yeah, look at the same graph when you do it.
I was like, no.
All right, I'm gonna stop because